going to look at how we graph to the fifths, and then we'll go back and look at the fourths. So the fifths and the thirds are very similar, again, because we call these parent functions, the original ones without any shifting or changes. The parent functions all look very similar. As we go up in power, it becomes steeper, and then one left and right of the vertex, it becomes flatter. Okay? So if we go and we look at our fifth power, here's our fourth power, fifth power, okay? If we look here, if I change my h value, so as I go positive, it goes to the left. If I go negative, it goes to the right. So it follows that same shifting pattern, that it's the opposite direction inside the parentheses, because that's where our h is located. The k, notice it shifts up and down. Even if we move this over and then we move the k, it just shifts it up and down. So our k value, and as we go up in number, it goes up in where it's starting. And as we go down in the k value, it's going down on the graph, right? So our h and k still do the same things for our fifth power. Now, if we look at the a value, we've got, this is changing its steepness. Okay. The a value still impacts the steepness, and it also changes where it's what am I saying? Which direction it's going, if it's increasing or decreasing. Wow, that took my brain way too long. Now, there is, if we go and we look at the a value, when we've got our a value, so if this is our -1, if we're in between -1 and 1, notice our graph is getting wider as we go in between -1 and 1, right? Because 1 is our normal one. So as we go less, notice it's getting wider and wider, and then I flip over here, and then we really be starting from, if we go from -1, that's our normal one, and then we go here. So if your a value is in between -1 and 1, it's getting wider. If your a value is positive, it's increasing from left to right. If your a value is negative, it's decreasing from left to right. If your a value is more than 1, notice it's getting this steeper pattern, right? Which is the same thing that happened with the cubes. So we have a pattern with our fifth powers as well. So our fifth power pattern is 1 in 31, which notice that's a lot more than 1 in 7, which that should be the case because as we're going up in power, we're getting steeper, which means we're going up faster. Right? Now these patterns come from your x values, right? So if you were to take the x values of 0, 1, 2, and 3 for x to the fifth, you would get 0, 1, and then your 2 to the fifth is 32. Whoops. And then your 3 to the fifth is 243. So notice you're going up really fast. So from 0 to 1, we went up by 1, then we went up by 31, and then if we do 243 minus 32, that gives us 211. So this is how we come up with the patterns for our polynomials. Okay? And then whatever we multiply the a value by, we multiply that pattern by that, and that gives us our new pattern. Okay? So we're going to look at graphing these four. I'm going to use this one here with our different colors. Okay? So on this first one, we're still going the opposite direction inside the parentheses, and then we'll go the same direction outside the parentheses. So here we're going to go right by 2. There's nothing outside, so that means I'm just shifting up by nothing. Right? So all I'm doing is going right by 2 and it's shifting up by nothing. It's a fifth power, which means it's got that disco shape. Since it's a positive a value, our a value is that unsaid 1, that means it's going to be increasing as we go left to right. So we're going to go right 1, up 1, right 1, up 31, which is obviously well off our graph. So for x to the fifths, you generally will only need the 1. If you have a fraction out in front, sometimes you'll be able to do the 1, the next one over. But generally speaking, it'll be nice and steep. So left 1, down 1. And then as I go to graph, I make sure I'm being really careful not to go too far past this next one, because really I'm supposed to be up 31 more before I hit this next x value, right? So that gives us our value for this. Now, or our graph for this. If we look at our domain is how far left and right we go. Well, this, as it's going down, granted very sharply, it will still continue to go over, and as it's going up, it will still continue to go over. So we're going all the way to the left and all the way to the right. The other way you can look at it is for the domain is there any problem that comes from plugging in any number into the equation? So you would run into problems when you have dividing by 0, when you have negatives under a square root. Those are the two cases that you know about now, and then we'll add another one later. Okay? But there's not any number that would be problematic for me to plug in. Okay, so that means that our domain is all real numbers. And our range, we're going all the way down and all the way up, so our range would also be all real numbers. Okay, if we take a look at our next graph, here, see if you can find the vertex for number 6. Okay, so we're going to go the opposite direction inside the parentheses. So that means we're going left 6, same direction outside, so down 1. So left 1, 2, 3, 4, 5, 6, down 1. Okay. The a value is a positive 1, which means that I don't have any change with my 1 and 31. So right 1, up 1, right 1, up 31. Again, because it's a 5th power, I know that it's that disco shape, and then since the a is positive, it's increasing from left to right. So from my vertex, I'm going to go left 1 and down 1, and then I'm going to create my picture. Okay. Again, it's still, since it's that disco shape, you're going to be going all the way down and up and all the way left and right. So your domain and range for both of these are going to be all the way from negative infinity to positive infinity. So for our x to the 5th, we call it quintic sometimes. I don't usually refer to it as that, but every once in a blue moon you'll see that. But our domain is negative infinity to infinity, and our range is also negative infinity to infinity. The other way that you can represent that is all real numbers. So it's like an italicized R that we're trying to write with just our hand instead of on the computer. Okay. So if we look at the next one, see if you can find the vertex for this next one. Okay. This one, I'm going to come write it over here. We have negative x to the 5th plus 4. So there's nothing inside the 5th power. So it's really an x plus 0 to the 5th and then plus 4. So this means that we're shifting left or right by nothing and then up by 4. So I'm just going to go 1, 2, 3, 4 up. And then our a value is the negative 1 out in front, right? So that means I'm going to take the negative 1 and I'm going to times it by 1 and 31, which is negative 1 and negative 31. So because the a value is negative, we know that it's going to be decreasing from left to right. And because it's a 5th power, we know that it's going to be going disco shape. So left 1, down 1, left 1, up 1. Oh, sorry, I totally said that wrong. Right 1, down 1, left 1, up 1. And then from there, it'd be up and down 31, which is well off our graph. So then I'm just going to make my graph picture like that. See if you can get the last one all the way. Okay, if you're not done, you can pause the video. So here we're going to go the opposite direction inside the parentheses horizontally. So I'm going to go right by 8 and up by 4. So I know there's 10 squares here, so I'm just going to go back to 8 and then up 1, 2, 3, 4. Our a value is the unsaid 1 out in front, right? So I could go over 1 and up 1. It's a positive a, so that means that we're increasing from left to right. I know it's the disco shape because it's a 5th power. So then we get this kind of shape here. Now, if I had done 2 times, let's do x minus 8 to the 5th plus 4. Okay, if I had done, perchance, that one, we'd start in the same spot, then I'd go over 1 and up 2, and left 1 and down 2. So I'd get this kind of a shape. So just know that that's how you would do with a number, do it with a number in front. Okay? And that's how you graph x to the fifth.